All right, here is how your drawings should look. Remember, it's okay if you do not have the dots, the unshared pairs, but your bonds need to be the way you see here. So here's the first one, a C in the middle with 4 F's around and all single bonds. Here's the second one, and as long as you have the bonds correct, if the N and the F are reversed, it's okay as long as you have 3 bonds with the N. And here is the last one. And again, that S could be coming out a different side as long as it has the double bond and there's 2 H's with single bonds. So you can stop here if you don't need help, but if you want help, I'm going to go through each of these. So for CF4, we know C is in group 14, so it has 4 valence electrons. Ooh, that's too thick. And 4 bonds. I like to write that above and below, 4 and 4. And then fluorine in group 17 has 7 valence electrons, and it makes 1 bond. 8 minus 7 is 1. Now the rule is put the one that needs the most bonds in the middle. Since carbon needs 4 and fluorine only needs 1, put carbon in the middle, and I have 4 fluorines to work with, so I'm going to put 1 around on each side and start by connecting with a single bond. Now check your bonds. Does everyone have what they need? The carbon is supposed to have 4, and I see it has 1, 2, 3, 4. That's good. The fluorine is supposed to have 1, and when I look at this fluorine, it has 1, 1, 1, 1. So everything is happy. If you leave it like that, you will get full credit. But really, these drawings are supposed to also show the unshared electrons, so I'll review that for those who are trying that. When you see carbon has 4 electrons and all 4 are in the bonds, there's no dots on carbon. I also see there's no dots on any of my carbon examples here. On the other hand, F with 7 valence electrons and only 1 in the bond, that means 6 are left as dots. So I'm going to put 6 dots around each one. And that looks like what we see on the F here with the green dots. All right, let's go to the next one. Get rid of, there we go. All right, bonds, or valence electrons and bonds first. We just did F, so I remember it was 7 and 1. And we just did C, and that was 4 and 4. Now N is over here in group 15, and it has 5 valence electrons and 8 minus 5, 3 bonds is what it needs then. Now we have F with 1, carbon with 4, N with 3. So both carbon and N need a lot. I'm going to put the C in the middle and then the N. And then since carbon needs 1 more than the N, I'm going to put the F next to the carbon. If I put it this way, I might realize that N can get a lot of bonds, but carbon is going to have trouble getting its bonds. So that's why we always put the one that needs the very most in the middle. Start with single bonds. Now count and see if everything has what they need. Looks like F needs 1, and here I see F with 1. That's good. Carbon needs 4, whoops, and it only has 2. So that's a problem. And so what about N? N has 3, and it only has 1. So carbon needs 2 more to get to 4, and N needs 2 more to get to 3. So that means I'm going to add 2 more bonds here, a triple bond, turns it into a triple bond. So that's it, and you'll get full credit for that, but let's talk about the dots. With F, remember It's got 7 valence electron and only 1 in the bond, so that means 6 are left over as dots. And with N, we see 5 valence electrons and 3 are in the bonds, so that means 2 are left over as dots. And that will also match the bond chart if you look at it closely. Let's try the next one. So here I see carbon again. I'm remembering that that's always 4 valence electrons and 4 bonds. S, that's one we haven't seen for a while. And I don't even see it here on this chart as an example, but that means it's just not the top one in the group. So S is in the O. Sorry, I have this extra writing over here that I forgot to erase, but so S is under O, and I see it up here. Hopefully you have yours if this is too blurry, but it says S and O are in that same group. So S and O both have 6 valence electrons and 2 bonds. 6 valence electrons, and then 8 minus 6 gives you 2 bonds. And then hydrogen, we haven't seen it on this worksheet. We see it a lot, but not today or not this time. So hydrogen, remember, has 1 valence electron, but even though it only has 1, it only wants 1 bond. It's the exception to the octet rule. So 1 and 1. Now the one that needs the most the one that needs the most bonds goes in the middle. So I'm going to put C in the middle. And now I have S and 2 H's. So I'm going to start with an S and an H and an H. And I'm putting them all around the carbon because I know it needs 4 bonds. Start with a single bond, and then let's count. Carbon needs 4. It has 1, 2, 3. So I'm going to need 1 more somewhere. Let's figure out where it can go. S needs 2, and this S only has 1. So maybe that's where it should go, but let's double check. H needs 1, and both H's have 1. So we don't want to put anything between the H and the C. I also want to make sure you know you don't just put a bond up here to nothing. It has to bond to something. So because S and C both need a bond, we're going to put it between them, and it's a double bond. And now the dots, 4 and 4, all 4 electrons are in the bonds. For carbon, no dots. But for sulfur, 6 and 2, that means there's 4 dots around sulfur, just like we see on the oxygen on the bond chart. So sulfur looks like oxygen. In this case, that sulfur is looking like that one, the 4 green dots. On mine, they're blue. And then hydrogen, 1 and 1, that means there's no dots because the 1 valence electron it has is in the bond. Notice in the way I drew it this time, it did turn out with the S over on the left side, and up here on my key, it turned out with the S on the right side. That doesn't matter as long as that's where you have that double bond, and then the H's just have 1 bond. So this is just like we're looking at it from behind, and maybe down here we're looking at it from the front if we walked around it and saw it from the other direction. All right, I hope that helped.